In the planning process, the second piping system had been planned, and in the second piping system, only the grey water from shower and bathtub are connected to the system. If I'm planning a new grey water recycling plant, I will also work with the water which comes from kitchen, which is high polluted, and I will also work with the water which comes from the laundry, which is also much more polluted than the water which comes from shower and bathtub. And we have other places where we are dealing with these high pollution components, and that is running very well. But here it is only bathtub and shower. And I said it is a very interesting point also to realize energy recycling. So the idea with energy recycling with grey water in combination with rainwater is not new. We had it in the old project in block 103. If we are talking about new systems, decentralized systems, first we have to look that there is no hygienic risk, of course. The second thing is it should be high tolerance for the people, because they don't want a loss of comfort. They are used to flush their toilet with drinking water quality. This is stupid. But if you have a new system, it should be working as well as the old. And the old system is working. They don't take care of it. It runs automatically. And this also should run automatically. I think there will be no wide acceptance. And so these are the main tasks in this project, to reduce the energy cost, not, as Ahmed said, with the old system having 3.5 or 4 kilowatt hours per cube meter. We reduced it to 1.5 kilowatt hours per minute. And this is sometimes much better than the conventional system which we have in the cities. We are dealing with less than 1.5 kilowatt hours per cube meter, cleaning the water, making the energy recycling, and pump it back to the toilets. It's now the pump is running and it's a little bit noisy. This is also a thing. We have to reduce noise. We have to find out what the people want, and we have to deal with it. We have to fulfill it. Otherwise, you will have no chance. 123 persons are connected to the system. We are collecting separately the shower and bathtub from the other. And so the water, the grey water, there are always hair inside. You see, I lost a lot of hairs. They are in the grey water. And so, because you have to make sure that the pump is working for a long time, you have to remove it. You have to remove this to make sure that the plant will run for a long time. So in the beginning there is a sieve, and the sieve is also self-cleaning. It is self-cleaning. So how we do it, how we realize, I will show you later. If so, the water comes from the bottom, and if the sieve is dirty and the water can pass, there is a pressure, and if the pressure goes over a several point, then we open it and we clean it with our treated grey water, clean the sieve, and then it goes like it goes. So we removed all the solids, and so the pore size of the sieve is about 0.2 millimeters. It's a very fine sieve, so no hairs can appear. As a planner, you have to take in consideration that the plant doesn't work only for maybe for 5 years. It should have a long running time. The warm grey water comes into the system. Sometimes it comes maybe 2 bathtubs are open, and it comes a lot of water, and we have to bring out the heat of the system. And so by law it is not allowed to have, for example, a drinking water pipe which is cold, and the wastewater pipe is warm, to have a cross heat exchanger. This is not allowed, because if you have corrosion, then can be a cross connection between the drinking water and the wastewater. This is not allowed by law. So we have to install a second cycle. So we take out the energy. This is a heat exchanger, and also this heat exchanger, as the sieve, it is self-cleaning. So we take out the energy of the grey water, and we bring it to the storage. This is a buffer. And now all the energy is going to the buffer, and now the cold water comes from the community. In winter time it is less than 10 degrees, and in summertime now I think it is, we can look later on the computer, it is 15, 16. What we are doing, the cold water comes in, let's say 10 degrees. We preheat the cold water, bringing it from 10 degrees to, let's say, 25. And from 25 to 60, which is the normal temperature, this can be done by a boiler, or in this case, it's a combined heat power station. It would also produce a lot of electricity. So, the energy is in the buffer. And so, what we are doing with the grey water, which is more colder than before. We have here, this is the first basin for the grey water treatment plant. This is storage of the grey water, and also pre-treatment. A pre-treatment means made, let's say, about 80% of the organic load is reduced here in these two basins. Then, after the grey water is pre-treated, we gave it to the final treatment station. This is this. So, and how it works? Both steps are working only biological. We never add chemicals to the system. All the bacteria are doing the work. We only add air, and these small air pumps. They are responsible for all the cleaning. So the microbes, they need enough air to fulfill it. And we want to make sure that the people don't see a difference. And so to be sure on the hygienic side, we use only UV disinfection. And so at least we came to the conclusion to reuse the recycled water for toilet flushing and for laundry. The quality should be close to the EU guidelines of recreational water. If you go to higher guidelines, let's say 0 E. coli in 100 milliliter, then you need additional chemicals. Otherwise you can't realize it. The result of this is that we invest about 1.5 kilowatt hours per cube meter of grey water for the treatment, for the heat recovery, because heat recovery also need a pump, and to the distribution of the treated water. But what is the benefit? We have about making from 1,000 liters of wastewater, we are making 1,000 liters of high quality non-potable water. And we earn about between 10 and 15 kilowatt hours heat energy. Especially architects, they are asking what are the costs? And so the cost, So this is a prototype, and as you can see, all these basins are handmade. But now we are not on the stage that I can buy it from a company. And if we come to this point, the costs will maybe they are half. All has about investment cost, include tax of about 52,000 euros. If you have grey water recycling, you have additional cost of about 11 euros per square meter. This is 0.03% of all. And then, because sometimes people say, oh, it's additional cost and it's very expensive. I think less than 1%, much less than 1%, 11 euros from 3,000 or more. I said, about what we are talking. We are recycling more than 1,000 cube meters of grey water, bringing it to non-potable water. So 1,000 water savings of about 1,000 cube meters means money savings of about 5,000 euros. What we earn from energy is about 13,000 kilowatt hours per year. And this is around 1,000 euros. The other point, maybe it is maintenance, because our system is connected to the internet. I have all data had been written on a SD card. I know every minute, is this pump on or is it off? And I have a perfect monitoring. If more than 1,000 liters of potable water comes into the system, because this system is not running well, I got an SMS on my telephone. So for architects also it is important how much space we need for the treatment plant. The development goes to make it more and more closer.